Hi, this is Dr. Greggs with the California State University at Northridge Geography Department with the video tutorial designed to help students learn to use the chi-square test to do contingency table testing. Basically, that's to see does an observed pattern replicate an expected pattern of data. And for this exercise, we'll be using some water usage data from the drought years out of Santa Clarita. Now, the chi-square test requires categorical data, and so we have water usage data that is not in categories. So the first thing that we really need to do is process the data so that it's in categories. Let's do a couple of things first. Let's start out by taking an average of the water use for 2014, 2015, and 2016. These are the three major drought years that we have. And just type in average and then highlight the data that you find in these yellow cells. And now that includes all of the observations for the year 2014. And then repeat that process twice again, once for 2015 and again for 2016. So the next thing that we want to do is to put that water use for each of those years into a category. And so we're going to type in here 2014. How about C for category 2015 C and 2016 C. And over here in cell BB, let's establish our categories. So for those households that use between 0 and 10 CCFs, we're going to call them low users. Between 10 and 30, that's roughly within one standard or a half standard deviation, we're going to call those users average. And then in the third category, we're going to call those users high if they use between 30 and 60 CCFs. And anything over 60, we'll call them extreme users. These are the mega users of water that are using 60 CCFs on average per month. So then we need to establish a lookup table. And lookup tables are extremely useful, and that's why I'm throwing them in this assignment so you have some experience with them. A lookup table does the following. So type in equals and then VLOOKUP. And what we want to look up is this value here, 21 CCFs. And then we want to find that value in this block of data over here. That's now in the red chase lights. Press the F4 button and that inserts $signs in front of each of the cell references to freeze those in place. And what we want the VLOOKUP to do is to look for the values in the column BB that has the numbers, and if it finds something in those ranges, then return what's in the second column of that block of data, which is column BC, and it has to be exact. So we'll type in true, close parentheses, and press enter. And so this makes sense that this user is an average user at 21 CCFs when we said anything between 10 and 30 is average. So copy that formula twice to the right, and we see that in each year that this user is average. If we copy it quickly down here, we see that this user, well, we have to copy their averages, was high and high over 30 CCFs until the third year of the drought, and then they became an average user. So Let's copy these formulas for all 6 cells, and once you've put them in the clipboard, double click in the lower right hand corner and paste these formulas all the way down. And so now we have averages in these 3 columns here, and we've categorized each of the water consumption over in the next 3 columns. This next step is to create a pivot table of this entire block of data. So click somewhere in the data block, anywhere, and click Insert and Pivot Table. Going to put it in a new worksheet ply, click OK. And here we have the pivot table, which will help us very quickly arrange our data by categories. To do this, grab Zip, click and drag it down and put it in the Rows box. Scroll to the bottom of your data and grab 2014C, put that in the Columns variable box, and grab it once again and put it in the Values. And we want a count, so we see the number of observations in each category, average, extreme, high, and low. Unfortunately, once again, this zip code and this zip code do not have enough observations. We need at least 5, and they don't have 5 in all. So we will filter them out by clicking on the row labels and deselecting 91380 and deselecting 91390. Now we have a table of observed values. One of the things I would like to do is grab the extreme cell and just drag it over here. That's a click and drag. You don't need to do that for sure, and then I can do that again with low, click in the cell and then drag it over to average. So we have low, average, high, and extreme. The software wants to alphabetize things, and we would prefer to have it logically arranged. So these are our observed counts for 2014. So what we're going to do is highlight this block of counts, copy them, and then paste them down here as values. So these are the data observations here, and I'll put them in a color. And we're going to use the data in the grand total and these grand total columns to calculate the expected. So let's type in here, this is observed in the brown cells, and down here we're going to do expected based on our calculations. So we can grab this once again, and we'll just copy this down so we don't have to retype everything, and then we can delete this and change the color on it to blue. How do we know how many we should expect? Well, we do that by first calculating the percentage of the zip code, the percentage of the observations in each zip code. For zip code 91321, there are 1,465 observations, and we want to divide that by the total number of observations, which is 8,238. Press F4 to freeze that cell reference and press enter. And so we see that that's roughly 17% of the observations, and you can copy that formula down to the rest of the cells below. Next, we can go to our expected table and say, well, if there are 17% of all of the observations are from 91320, then, and there are 1,665 low observations, people who are conserving water pretty well, we can multiply that by the percent in that zip code to get an expected number, and it should somewhat echo the 674 that we have here. And I'm going to press enter, and we see that it's 296. So that's quite a bit fewer than we would expect. We want to go back into that formula and modify it so that when we copy it, the row 19 variables will be frozen. So that's putting a $ in front of the 19 in the first half of the equation, and then we want to freeze column G over in the % of zip code observations, and we just have to press enter at that point, and then we can copy this to all of the blue cells. These are now our expected variables. In order to calculate the chi-square test, we need to engage the formula that has magically appeared on the screen. Chi-square is equal to the sum of observed minus expected square divided by expected. So let's go ahead and do that. So here's our observed. So we can type an equal sign, open parentheses, there's observed minus expected, and we want to square that. That's a caret and 2, and then we want to divide that by, once again, expected. Press enter, and then you can copy that formula over 4 and down 4, and now we have a chi-square contingency table that we can ask the sum for. So we can sum each row and get the chi-square for each zip code, and in this case you can see that 91350 has the smallest chi-square value, and so therefore confirms most closely, and then 913210 is most unexpected. We can highlight this block of data and place conditional formatting on it, where the highest numbers are the ones with the greatest contribution to the chi-square, or they're the ones that are most off what you would expect. We can also sum the entire thing and get a chi-square value for the entire block of data. The last thing that we're going to do is just ask Microsoft Excel to calculate the whole thing for us. Its chi-square test is the test we want to use, or the formula we want to use, and you take the observed as the actual range, highlight it, enter comma, and then highlight the expected range. And not only what it does is gives you not the chi-square result, but the probability that you would be making an error if you said these two were different. And oftentimes this will show up as scientific notation, something like that, or if you prefer it in numbers value, it's just like that. And so your chances of making a mistake if you said that this block of data was different than this block of data is extremely small. One last thing, just to check our work, is if we, and this is a temporary thing, if we take the observed, copy it, and paste it into our expected, notice all of the values drop to 0, and we can change just maybe 1, and then we see here is our chi-square value, and here's our chances of being wrong, which is 100% if we argued that these two blocks of data were different, because they are the same. Press Control or Z to go backwards and undo your results. Save this and submit it to your instructor for credit.